Okay, so we're going to start day one of section 14. We're going to start talking about three-dimensional objects, and today specifically we're going to talk about taking those objects and unfolding them into what we call a net. So a net is the composition of two-dimensional faces that's formed by unfolding a three-dimensional figure. This down here is an example of a net, as well as these are all examples of nets. So they're a three-dimensional figure that have been kind of cut along the edges and unfolded. Three dimensions they're called that because they have three dimensions, length, width, and height. So they have length, they have some width, and then they have height. Three-dimensional solids have four components. They have faces, that'll be like along the sides. They have edges, which are where the faces meet. Vertices, which are the points, and bases. So consider the following net on the right. Identify the bases and the faces. So the base is this number 1 here. The faces are all around the outside. So when you fold that up, you're going to have these triangles that come up, triangles that come up. They're all going to meet at the point up here and form a pyramid. So the faces are 2, 3, 4, 5, and 6. When we fold all of these up, the 2 is going to fold up, the 3 is going to fold up, the 5 will come over, the 4 will fold up, and the 6 will come kind of over. And they'll all meet at a point up here. That makes a pyramid. So looking at these 4 nets, I want to know which of the following ones will fold up to be a cube. I'm going to give you a minute to look at those. I want you to just circle the ones that you think are going to fold up to be a cube. A cube is going to look like a die, like a dice. Okay, so when I fold up this one, I have a top and like 2 sides, and then that one's going to fold in, but it's going to overlap with this one. So that one's not going to fold up to be a cube. This next one is going to fold up to be a cube. This would be the top, and that's a side, and that's a side. That one's going to fold in to be the side over here. That's a side, and that's going to be the bottom. For the next one, let's say, it doesn't matter which one you choose to be the top. So that's the top. That's going to be that side on the back. These are 2 sides on either side. That'll be on the front, and this will be on the bottom. So that one also works. There was no overlap there. With this one, let's see. Let's say that's the top, and then these are all sides. That would be the bottom. But then this one would also be the bottom, so we can't have two bottoms on the cube, so that one does not work. So drawing nets. A prism is a cube, or it can be a rectangle. It can be a triangle. We're going to talk a lot about prisms in the coming days, but these are nets of prisms. I'm going to draw a rectangular prism though. So that's going to be, I'm going to draw the actual three-dimensional version. So I draw a rectangle, and then I draw another rectangle that's kind of like offset from the first one, but it's the same size. And then I connect the corners. So if we unfold that, have the base here, the 2 sides flap down on either side, The front and the back are going to fold down. Those are rectangles. And then we need the top. The top can be on any side. It just is going to fold over. So I'm going to draw the top here. That's where I had the room. A pyramid. Drawing a pyramid, you can draw a triangle. And then draw another line off from the side and just connect it like that. And then you can draw a little dotted line back to show that the base is a square. The base does not have to be a square, that's just the most common. Up here we had a pyramid and the base was a pentagon. So for this one I'm going to draw the square. That's my base. And then all of the sides are just going to stay connected to the base and fold straight out. It's almost like unwrapping a present. A cylinder is a circle on the top and then a circle on the bottom. It's like a can of soup or a Coke can. The net for this, we have our bases, that's a circle. The lateral part of this, if you picture a label coming off of a can, it comes off of the can and it's always a rectangle. So that rectangle wraps around it, and then you have the other base on the other side. And then finally a cone. A cone has a circular bottom, but it comes up as a triangle. A cone's net is a little weird. It has that circular bottom, and then it's a triangular shape, but it's curved at the bottom so that it can wrap around the circle perfectly and still come to a point at the top. So which of the following will fold to be triangular prisms? So prism means it's got to have a top and a bottom. If it's a pyramid or a cone, it comes to the point. If it's a prism, it has a top and it has a bottom. So when we fold this up, we have a triangle, have a top and a bottom, that is a triangle. So when we fold this up, that's the base, that's the top, these are all three sides. So figure 1 works. Figure 2 also works, and figure 3 works. Figure 3 is the easiest one to see, I think. You just fold the two edges straight up, and then fold these two straight up, and they meet in the middle. Okay, go ahead and turn the page. So here we're going to talk about rotating solids around a line to make a three-dimensional object. A revolving door is a good example of that. So you take that door and you revolve it all the way around, and it's going to trace a circle or a cylinder. So you've taken this rectangle and it revolves so people can walk through it, and it ends up creating a cylinder. That's why you have that big circle for the door to revolve in, because that's the shape it traces. So when we look down here at this picture, we're going to take this triangle and revolve it around that axis, that vertical axis, the y-axis. And I want to know which shape is created below. So it comes to a point at the top, so it's going to come to a point. So it's either going to be a pyramid or a cone. But this is going to create a circular bottom. So it's going to have point at top, circular bottom. So that means it's going to be a cone. This one, It's just like the revolving door. When it rotates, it is going to create a cylinder. And then last thing for today, I believe. Yep, last thing for today are cross sections. A cross section is a slice of a figure. It can be straight up and down or straight left to right, so vertical or horizontal. So we take this figure and we slice it. Vertically, we're going to slice it this way. Horizontally, we slice it that way. So think about, let's see. If you've ever cut into a block of cheese, when you slice it, what shape you're seeing on the end. So here, vertically, when we slice this, we are seeing a rectangle still. If we sliced right here and we took that piece away, we ate it or whatever, if it's cheese or whatever it is, we're going to be left looking at a rectangle still. Horizontally, if we slice like that and we take the top off, we're going to look down and see a triangle. Also, this is a triangular prism, just for the record. And this is a cone. Vertically, here, when I slice it from the tip top down to the bottom, I'm going to see a triangle when I just look at it straight on. Horizontally, when I slice straight across, left to right, I'm going to look down on it. If I slice just this little top off, I'm going to look down and I'll see a circle. And that is it for our Day 1, Section 14 notes.